Welcome to the part 3 of lecture 7. This part is going to be a hands-on with R on how to estimate maximum likelihood estimator for logistic regression. Hands-on that we are going to discuss today, I'm going to show you actually a very generic recipe for that can work for any statistical model that you want to develop for any kind of data analysis work. So if you have a data, if you have a problem, first thing is you develop a probability model and then you write down the likelihood function of that probability model given the data, and then you pass it through a optimization subroutine. It can be in R, it can be in Python, it can be on MATLAB, any statistical software which can do general purpose optimization. And the solution of this likelihood will be the maximum likelihood estimates of this probability models, and that you can is used to predict for the future observations or any test point. So for this hands-on, I'm going to use the German credit score dataset. So for that, you go to Google and write German credit score. So that will take you to the UCI machine learning repository where the German credit data is available. It's a nice data set in a sense, though it is a little bit older data. It was donated on 1994. It has only about 1,000 samples. Typical credit score data, you can have a millions of samples, but here you have only 1,000 samples. But for learning purpose, I think it's a good data to, you know, uh, be good data to start practicing on. So in this data set, you have one variable called good or bad, whether a loan was given and the loan turned out to be good or bad loan. 1 equal to good and 2 equal to bad. So what we will do at the first, we will subtract the value 1 so that 1 will become 0 and 2 will become 1. So 1, for our case, what we will recodify it as a 1 equal to bad and 0 equal to good. And it has also about 20 attributes for each of the samples. You can go down and you can see about 20 attributes are there for the samples, for each samples. So we will go back to, I already have downloaded this data and it is there already, so I can just call it. Let me run, and if you just click on this, then you can see that 1,000 rows are there, and this is the first attribute, uh, status of checking account. You can see this is a label data or attribute or qualitative data. So when we will do analysis with such kind of data variable, what we have to do, we have to create dummy variable like 0 1. For each of the levels we have to create some dummy variable 0 1. In machine learning also it is known as one shot hot encoding. And there are some numeric variables, duration in month and then credit amount. So for our purpose we will only use the numeric variable because our main focus is to learn the how to use general purpose optimization to solve the maximum likelihood estimation methods. So without any further delay, we will start with that. The first thing what we will do is, if you once more go back to the data, if you at the end you will see good and bad is coded as 1 and 2. 1 means good, 2 means bad. First thing what we will do, we will subtract 1 from there. Data dollar good and bad equal to data dollar good and bad minus 1. So if you again now run it, so if you go there, now 2 is being converted into 1 and 1 is being converted into 0. So 0 means it is a good loan and 1 means it is a bad loan. So next what we will do, first we will split the data into train and test. About 70% data we will keep in the train dataset and 30% data we will keep as a test dataset. So first thing we will do is so we have total, this is the total data size. M is the size of the train dataset that we are going to decide. So M is 700 and N is 1000. Next what we are going to do, we are going to set the seed. You can give any number. I'm just giving just one such number, and then I'm going to sample the ID for the train dataset. Data train equal to you just write data and then give the comma, and left of this, these are the row numbers effectively. So if you look into the first few numbers, train ID, so these are the row numbers which will go 552 row, 201st row, 58th row. These are the row numbers which will go for the, which is being selected as for the train data set. So and then data test is data minus train ID. So this will be our, so you can see now we have train dataset with 700 observation and test dataset with 300 observations, and these are the disjoint to train and test dataset. So we will fit our model on the train dataset. First we will fit the logistic regression with the built-in function in the stats package, and then we will pretend as if this stats package is not available and we have to build it, we have to write a code from the scratch, and we will try to solve that from solve the fitting the logistic regression from the scratch. First we fit logistic regression using built-in function in R. Okay, so for that I just name that fit glm. So in the stats package there is a function called glm, and we can do this good bad dollar scale. I just need the columns of data. So good bad is the target variable, and duration in month we are going to is the one predictor that we are going to use, and skill is the say credit amount, and data equal to data train. Now if I glm, if I just run this, summary. Okay, I forgot one more thing to actually, I have to write family equal to binomial, and then within binomial link equal to logit. I have to use logit link. And now you fit this model, and then this is the fitted values. This is the fitted logistic regression. This is with logit link. These are the coefficient. This is the standard error, z value and p value. So clearly duration in month has a positive effect on probability of being a bad loan. So if duration in month increases, then the chance of bad loan increases along with it. A loan or chance of a loan becoming a bad increases along with it. So this is what we see. Now we pretend, second step is now we pretend that GLM does not exist and we want to code from scratch. Okay, so first thing we will do is we will model first we will write the negative log likelihood function for logistic regression. So for that what we need is this negative. So we will write negative log like as the function, and what are the things we be providing? Data, beta, and what we are going to provide y name and the x name, the name of the variables we have to provide. So the first thing we will do from the y, we will just take data comma y underscore name, and we'll do x is data comma x underscore name. Now in this x it will be only the predictors will be there, there will be no intercept part, so we have to add an intercept part to it. So what we will do, we will just add a cbind dot data dot frame as. So first also we have to do one more thing. In row of n1 is the number of row in the data. Actually let us use a slightly different naming convention, otherwise we will get confused because we have already used data. So let us call it dataset name. I mean it is not going to affect much, but it is better in that way. Intercept equal to replicate 1 comma n1 comma x. Now what I'm going to do, print the head of x, and then train comma beta equal to maybe 0 comma 0 comma 0, and x y name equal to good underscore bad, and what we need is x name equal to, we have to give duration in month and credit amount. Sorry, I have to compile this code first, then only it will run. So now it working fine. So first column is the intercept column of the x, second column is the duration in month, and the third column is the credit amount. So that is working reasonably. So one thing we can do here, it is we can just scale it, because remember that when we fitted this model, we fitted it as with the scaled parameter, so that we understand what is happening there. So we just scale that. If we scale that, then what will happen is we get these numbers. All right, cool. Next, what we are going to do is, the first thing we are going to do is we are compute the z, which is, we have to read it as a matrix, not as a data frame, and then x percentage star percentage beta, and print the head of z. I hope this works. Yes, so this is perfectly fine. Yes, because if we just change a little bit, 0.1, let us see what happens. Yes, this is working fine. Next, what we can do is we can compute the p as exp to the power z divided by 1 plus exp to the power z, and we can plot this print head of p, and we can run this. So these are the now probability evaluated at an initial value, some initial value of beta at 0, 0 0.1 and 0. Some nothing really major. If you give all 0, then it will become all half, I think. Yes. So now we go back, and now we are going to compute the negative log likelihood given the piece. So if we go and check our data, so typically that's how the negative log likelihood looks like: the sum of y times log of the p, this is the p, plus 1 minus y times log of 1 minus p. So that's how it looks like. So first what we are going to do, we are going to 0, assign a dummy variable, and then for I in, this is not the very optimal way of writing this code, but I'm writing purposefully so that you understand exactly what I am doing. If f equal to f plus y I times log of pi plus, we can 1 minus y I times log of p right? And then finally negative log likelihood must have a minus. This is if is computing the log of likelihood, we want negative log likelihood, so we just multiply it with -1. Just -1 should be fine. Return negative log likelihood. If I just do that, then it should be giving me this value. Very nice. Now our negative log likelihood is ready. Now what we want is we want to is optimize this negative log likelihood and estimate the beta at which this negative log likelihood is minimum, and we want to minimize this negative log likelihood. So in another way, it will maximize the log likelihood or likelihood function, and it will gives me the maximum likelihood estimates. So for that, I'm going to use something called optim function. So if you just write question mark optim, it is already there. So it's available in the stats package. It's a general purpose optim function. You can read it very carefully, but I'm going to just use this as optim. The first thing we have to give is par as some initial values, beta dot init. So what I'm going to do, beta init, I'm going to initialize this value as 0 comma 0 comma 0, and then function, we have to give a function. That function is the function which I want to optimize. So this is the optimized function, and then the we have to provide the data set name. In this function we have to give this data set name. What is the data set name? Data set name equal to data train. I'm going to use the data train, and then rest of the thing is pretty much this. Y name I have to provide y underscore name equal to good and bad, and x name equal to duration in month and credit. Alright, so I have to just write feed lr optim. That's what I'm trying to fit here. It is better to align them correctly. In this sense, I would say Python is pretty cool. I prefer Python because Python does a nice alignment automatically. It always encourages the best practices. R has this legacy things which actually does not. You have to do the alignment for yourself. Otherwise, I have to run the beta init, the initial value of beta. And it has run, and without any error it has run. So if I just, so it has taken 82 steps, and these are the estimated MLE. You can see that, and then what I will do is I'll just compare the estimates of the par. If I just say, so these are the maximum likely estimate of the beta parameters of the model, and then what you need to do is you need to compare this value with the fitted model. So we have fitted the model above fit GLM, and from the fit GLM we can, so this is the built-in function that we have computed. So this is the actually the negative 0.8924, this is 25, this is 0.4034, this is 4035, and 0.035 is 3 is the from the optimization, and this is 0.0355. So up to 3 decimal places it matches exactly. Then built-in function and the optimization, our scratch function, deviate little bit. So that's how you estimate the parameters. Once you estimate the parameters, you are pretty much done. And now what you can do, you can do the prediction for the estimate, or for the estimation for with the estimated parameters. How can you do that? So you can write the beta hat as sorry, I should do it in the data part. Beta hat equal to fitl or optim. So this is my, and now what you can do, we can just, you have to write the x test. X test will be basically skill of data test, and these are the name that you have here. And then also you have to be a bit careful, and then you just x test is n1 is in row of x test, and then so you just run that, and then x test percentage star percentage time beta hat will give you the z hat, and then p hat will give you the p hat will give you the z hat probability of bad loan in the test dataset. xp of z hat, and then actually data test dollar, you create this value, and then data test dollar good bad predict, and data variable got p hat, actually data test dollar p hat is your p hat, wherever you got greater than 0.5 you should be 1, and then you just create a table equal to data test dollar good bad versus data test dollar good bad predict. So this is my actual versus predict, and This is the actual accuracy. So with this, you probably got to now a sense that how to fit a statistical model using a general purpose optimization routine in a any standard mathematical software. You can use R, Python, MATLAB, Mathematica, SAS, IBM Watson, anything pretty much. So all you have to do, first you have to understand the problem. From the problem, you have to develop the probability model, correct probability models. Once you develop the probability models, then you have to write down the likelihood function for the probability models, and then you for the data that you using the data, and then all you have to do pass this likelihood function or negative log likelihood function through a general purpose optimization routine, and that will give you the estimates of the parameters. Once you get the estimates of the parameters, you do your test on the test dataset. So you do the optimization on the training dataset, and you do the test on the test dataset and check how your methodology is working, and how whether this particular model is probability model or machine learning model is good enough to take it further. Thank you very much. Keep watching.